This video is on triangle theorems, specifically the triangle midsegment theorem. The triangle midsegment theorem states that if a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and half as long. So if we come over to this picture, let me explain. Again, the theorem states that if a segment joins the midpoint of two sides of a triangle. So we have tick marks right here. This states that AD, segment AD, is congruent to segment DC. Therefore, point D is the midpoint of segment AC because it's in the middle, it's cutting them in half. We also have two tick marks over here. We have segment BE is congruent to segment EC because of the amount of tick marks. Therefore, point E is the midpoint because it's in the middle of two congruent sides or two congruent parts. Therefore, segment DE is considered the midsegment. So again, going back to that theorem, it states that the midsegment, if you have a midsegment, then the segment is parallel to the third side and half as long. So focusing on the parallel part, the segment is parallel. Segment DE is parallel to segment AB. So we can use the markings to represent that. They are parallel, so we showed the arrows in here saying that they are parallel to each other. The reason the parallel will be helpful, if we go back to parallel lines and transversals, we have two parallel lines, and we actually have two transversals as well. Parallel lines and transversals have those 5 angle pair relationships, the corresponding angles, alternate interior angles, alternate exterior angles, same side interior, and same side exterior. So they have relationships between them. So those can help us if we're dealing with measurements or with angles. The theorem also states the segment, if we have midpoints, then the segment is half as long to that third side. So it'll be half as long. What that means is that DE, segment DE, is half the length of AB. So we can say that DE is equal to half the length of AB. Notice I did not put the segment on top of it because we're talking about the length. So the length of DE is half of AB. But what if we know what DE is? Instead of trying to find DE, what if we know what it is? And we're trying to find AB. So we can rewrite this and say that the length of AB is actually equal to 2 times the length of DE. And if you think about it, it would just be multiplying by 2 to get rid of the fraction. We'd have 2 times DE is equal to 1 AB. So that's the same thing. But the reason we want to know that one as well is in case we have something that's not going to be good with fractions, then we can use this equation because it's the same thing, just manipulated differently. So if you were given the midpoints, if you have the tick marks, you can state all of this. But what if you're given the red? You have to be given all of the red, and you can say the black. If you're given the parallel and half as long, then you can tell me that you have midpoints. If you're given the black, if you're given midpoints, then you can say all of the red. So parallel and half as long. So on that theorem, you can go the first half, you have the second. If you are given the second half, you can tell me the first half. Just like it's the converse, just like in isosceles triangles. So let's look at a couple of examples. This first example says solve for x and the missing side lengths. So on this problem, we are not given midpoints because we don't have the tick marks, but we do have parallel and we have half as long. So we know that 6 is half as long as 12. So since we have parallel and half as long, I'm going to make a little note about that. We have parallel, that's the symbol for parallel, and half. We have half. We have the second part of our theorem. Therefore, we have midpoint. Since we have the second half, we can state the first half. Since we have parallel and half, we can actually have midpoint. That means, since these would be your third sides, we can say that this segment is cut in half, and we have two congruent parts to that. So we have tick marks on that one. But we also have on this side, we have these are cut in half as well because of the midpoints. So we have two tick marks on there. That will help us with the x because now that's attached to the congruent marks. So we can say that 2x plus 4 is equal to x plus 9. 2x plus 4 is equal to x plus 9. So if we were to solve this, we'd subtract the x and we'd subtract the 4. So we'd have x is equal to 5. So we solved for x. Now we find the missing side lengths. So 2 times 5 is 10 plus 4 is 14. So we have 14 units. Then we do 5 plus 9 is 14, which should be right because these are supposed to be congruent. So this is also 14 units. So we were given the second half of our theorem so we could prove the first half. But we had to be given the entire second half of the theorem. We had to be given both the parallel and half as long to be able to say midpoints. If we're given midpoints, we can say both of these at the same time. If we're only given parallel, we can't do anything. We don't know anything else. So that is the parallel symbol. That's not an 11. This is a parallel symbol. Go into this next example. On here, we are not given parallel markings. We do not know the lengths between these two, but we do have tick marks, which are congruent marks. So on here, we have this segment is congruent to this segment, therefore this is a midpoint. We also have segment congruent to segment, therefore this is a midpoint. We have a segment connecting them, therefore we have the mid segment. So we have midpoints. Since we have midpoints, we can then state, we have parallel and half the length. So if we come back down to our picture, we can put in there the parallel parts. We have the parallel, but we don't have any lengths on here, so that won't help us with a half length, and that's okay, because the parallel could still help us. Parallel goes along with angles, and x is actually in an angle, so that will help us even more. So I'm going to highlight in pink. I'm going to outline the angles so I can deal with those. I'm going to outline them. And now I just got to figure out the relationship between them. You can see that this pink on that highlight and this pink, they're both touching different parallel lines. And this part of the pink on both of them are touching the same line. That means that this is the transversal and it's cutting two parallel lines. Therefore, we have angle pair relationships. We just got to figure out which ones they are. So the x is located on the top of the parallel line and the right of the transversal. The 71 is on top of the parallel line and the right of the transversal. They're both located in the top right. That means that these angles are corresponding angles. The numerical relationship between those is that they are congruent to each other. So that means that x will equal to 71 degrees. This last example, we're going to solve for the missing variables. On this one, we have both x's and y's, so we have to make sure that we're really careful about which sides go with what. On here, we have no parallel lines, because it doesn't have any of the arrows. We don't know the lengths of anything, so we can't say half as long, but we do have tick marks, and tick marks mean congruency. So we could potentially have midpoints. So we have the y is attached to this line. We have tick marks right here. This is one tick mark, one tick mark. That means that this is the midpoint. So y is already a part of a midpoint. X is already part of a midpoint. We have tick marks here. Therefore, these are congruent to each other. So this is a midpoint. And we also have 3 tick marks here, 3 tick marks here. So this is a midpoint. So we actually do have 3 midsegments. This midsegment doesn't have anything on it, and it would be parallel to this length, which also doesn't have anything on it. So this midsegment will not help us. But this midsegment has x on it, and it goes along with the 3x minus 6. This midsegment has y on it, and it goes along with the 2x plus 1. Now, since the y and 2x plus 1, we can't find both letters at the same time, we don't want to deal with that one yet. So let's focus on the x, midsegment with the x on it, and the 3x minus 6, since those both have the same letters. Now, we can come back up to here, and we can say that the midsegment, the little side, is half as long as the big side. So we just have x is equal to half as long as this. But that's half of 3, and that'd still end up with a fraction. So we can try this one as well, that the longer side is equal to 2 times the shorter side. No fractions, and that would actually be a little bit easier to work with. So we'd actually have the longer side of 3x minus 6 is equal to 2 times your midsegment, 2x. Now we can just solve for x. So we'd end up subtracting the 2x, and then we'd add the 6 over. So we'd end up with x equals to a positive 6. So we have that first missing variable. Now that we have the 6, we can actually plug that 6 into here to figure out our numbers. So if this x is 6, we can just put 6 here. 3 times 6 is 18, minus 6 is 12. And 6 is half of 12, so we know that that is actually correct. We also have an x here. 6 times 2 is 12, plus 1 is 13. We still have to find the y value. So I'm going to highlight the y, that midsegment, and the midsegment that is the third side that's parallel to. So this time, we want to find the y. So if we look midsegment, the y is equal to half of this length. Still going to have a fraction, but if I do it the other way, I would say this length is equal to 2 times the y. That's more on the y. I'd have to get rid of it anyway, so might as well just keep the y as it is. So I'll use midsegment y is equal to half of this length. So I'll write this in pink. So our y is equal to half of that 2x plus 1. But we did find that that 2x plus 1 was 13. So we can actually say that y is equal to half of 13. When we write this out, we should say that y is equal to 13 over 2 because it's an improper fraction. That's our y value. Now when I plug it back in, 13 over 2 is 6.5. So I could put 6.5 right here. And 6.5 is half of 13. So that means that our values were correct. So again, you could be given the first part of the theorem or the second part of the theorem. And if you're given all of the first part, you can prove all of the second part. If you're given all of the second part, the parallel and half as long, you can prove the first part.